Okay, we are in 7.4 and we are solving linear systems by multiplying first. This is an extension of the elimination method, but at first glance, you cannot eliminate either variable by adding or subtracting initially. If you want to be able to use the adding and subtracting, you must multiply one of the equations or even both equations to find a common coefficient in order to use the elimination method correctly. Some of the examples I have, you're going to multiply one equation and then add or subtract, or I'm going to have you multiply both equations and then add or subtract. So let's look at the examples. If you look at A, I have 6x plus 5y equals 19, and 2x plus 3y equals 5. So here are the steps here in blue are how we solve for the elimination method when you can't add or subtract initially. You must multiply one of the equations. Um, First step is to make sure that both equations are in ax plus by equals c form, which is standard form. In this case, it is. So now all we have to do is look at which equation I want to multiply by. And if I look at 2x and I look at 3y, 3y I can't really multiply into to make 5y, but I can multiply 2x to make 6x. And I can do that by multiplying my entire equation by 3. So step 1 is to multiply one equation, which allows us to eliminate one variable. So I'm going to rewrite the top. So I got 6x plus 5y equals 19. Now I'm going to distribute that 3 throughout the entire equation. So this leaves me with 6x squared plus 9y equals 15. So now we're given an equation that is just like what we did in section 7.3. So now I look at it, my same coefficients is at 6x. Now, are they the same or are they the opposite? They're the same, so that means we're going to subtract our values. So that means I'm going to have a negative here, and a negative here. So this gives me with 0. This leads me to be a negative 4y equals 19 minus 15, which gives me 4. Now, dividing both sides by negative 4, I get y equals a negative 1. So now that's step 3. I solve for the non-eliminated value. Fourth step is once we solve it, substitute it into either original equation, keep that in mind, and solve for the other variable. So I'm going to use the top one right here. And so I have 6x plus 5, and I'm going to substitute in negative 1 in for y equals 19. So now I have 6x minus 5 equals 19. If I add 5 to both sides, that cancels, so that leaves me with 6x equals 24. And if I divide 6 to both sides, I get x equals 4. So my ordered pair here will be 4, comma, negative 1. If I look at B, I have 3x minus 2y equals 3, and negative x plus y equals 1. So I could eliminate either the x or the y in this case It just matters on which one you want to multiply. So I guess for this case, I'm going to eliminate my x. So that means I'm going to multiply my bottom one by 3. So I have my top, so it's 3x minus 2y equals 3. If I were to distribute that, I have a negative 3y plus, negative 3x plus 3y equals 3. And I'm going to eliminate my 3x. They're opposites, so I'm going to add them. So this becomes 0. Negative 2y plus 3y is just y, and that equals 6. So now that I found what y is, I can substitute y back into the original equation and solve. So what I'm going to do is I'm going to use this original equation, the negative x plus y equals 1. So negative x plus 6, because that's what my new y is, equals 1. I'm going to subtract 6 to both sides, which then gives me negative x equals a negative 5. But because I have a negative x there, I'm going to multiply both sides by negative 1, which then this leaves me with a positive x, and then negative 5 times the negative 1 is just 5. So my ordered pair for example B will be 5, comma 6. Looking at C, I got 2x plus 5y equals 3, and 3x plus 10y equals negative 3. I have both equations are in standard form, and I'm going to eliminate my y. So by doing that means that I'm going to multiply the entire equation by 2. So, which leaves me with 4x plus 10y equals 6. And then I got 3x plus 10y equals negative 3. And so if I'm going to eliminate my y, that means I'm going to subtract everything. So I'm going to have negative, negative, and since that's a negative there, that's going to be a positive. So 4x minus 3x is just x, and that equals 9. So now I'm going to substitute it back into the original equation. I'm going to use, let's use this one. So I have 3 times 9 plus 10y equals a negative 3. 3 times 9 is 27, plus 10y equals a negative 3. I'm going to minus 27 to both sides. 10y equals a negative 30. Divide both sides by 10. Y equals a negative 3. So my ordered pair here would be 9, comma, negative 3. Sometimes, like I said, you may have to multiply both equations, which mainly means is that you won't have, you can't, there's no least common multiple that they have in common in with both equations. So in order to do that, first you have to make sure, again, that it's in ax plus by equals c form. So I'm just for a, for instance, I'm going to look at a. I have my first equation is in standard form, but my second equation is not. In order to do that, I have to subtract both sides by 3x, which then gives me negative 3x plus 2y equals a negative 9. So there's no value for 3 to multiply, that'll get me 4, and there's no integer that for 2 that'll get me to 5. And if you look here in the parentheses, sorry if I smudged the writing, but what it says is the best thing to do is to multiply each equation by the coefficient of the other equation of the variable you wish to eliminate. So at this point, you have to choose which one you would like to eliminate. It does not matter which one you do, it's just you have to be consistent throughout the entire problem to eliminate. So what I'm going to do is let's eliminate the x value. So if I've already chose I'm going to eliminate the x value, then I have to multiply by the coefficient of the other equation. So if I'm going to multiply by the coefficient of the other equation that's attached to x on the other side is a -3. So I'm going to, we'll just multiply it by 3. And the coefficient of the first equation would be 4. So what you're basically doing is you're multiplying by the coefficients of the other, whatever the variable is attached to. So I'm multiplying the first equation by 3 because I have the 3 here. I'm multiplying the second equation by 4 because I have a 4 here. And now I can distribute my 3 and my 4 to both equations, and then we can start doing the elimination method. So I have 3 times 4x, which gives me 12x, plus 15y, and then 3 times 35 equals 105. And for the second equation, 4 times a -3 is a -12x plus 8y equals a -36. So now that I know that I'm going to eliminate the x and I see that they're opposites, that means I'm going to add both equations. So this becomes 0. 15 plus 8 equals 23y equals, then 105 plus a -36 gives me 69. And if I divide both sides by 23, y equals 3. So now that is what step 3 is here. We've solved for the non-eliminated variable. Now once we do that, we substitute them back into the original equation and then solve for the other variable. So what I'm going to do, I'll use this one. So now I got 2 times 3 equals 3x minus 9. So I got 6 equals 3x minus 9. I'm going to add 9 to both sides, which gives me 15 equals 3x. Divide both sides by 3. 5 equals x. So my ordered pair here would be 5, 3. Here's some more. Looking at b, is it in standard form? Is it in ax plus by equals c form? Yes, it is. So now I'm going to let's eliminate y for this case. So I'm going to multiply both equations, and I'm going to multiply them by the coefficient of the other, what the other equation is. So the top equation, I'm going to multiply by 2. And for the bottom equation, I'm going to multiply by 3. So now once I distribute it out, I'm going to have 8x minus 6y equals 16. And then for the bottom equation, I'm going to have 15x minus 6y equals a negative 33. Now, if I look at these same values, it's a negative 6y and a negative 6y. They're the same. And since they're the same, that means that we're going to subtract. So that means that this is going to be a negative, this is going to be a positive, and this is going to be a positive. So this is going to give us a negative 7x. This cancels out, and this equals 16 plus 33 equals 49. Divide both sides by negative 7. Our x equals a negative 7. Now, it's just a matter of putting this negative 7 back into one of the original equations and solving for y. Let's use this one. So I have 5 times negative 7 minus 2y equals a negative 11. 5 times, that's negative 35, minus 2y equals a negative 11. I'm going to add 35 to both sides. So negative 11 plus 35 equals 24. So I got negative 2y equals 24. Dividing both sides by negative 2, y equals negative 12. So my ordered pair would be negative 7, comma, negative 12. And our last example. I have 9x plus 2y equals 39. And I have 6x plus 13y equals a negative 9. I think for this one, I'm going to eliminate my x. You can eliminate your y if that's what you wish to do, but for this case, I'll eliminate the x value. So that means I'm going to multiply this one by 6, and then the second equation, I'm going to multiply it by 9. So when I distribute it out, it becomes 54x plus 12y equals 234. And then the second equation would be 54x plus 117y equals a negative 81. And I looked at 54x are the same. That means we're going to subtract. So that means that this becomes a negative, this becomes a negative, and this becomes a positive. So this cancels out. That means 12 minus 117, which would be negative 105y equals, and it's 234 plus 81, which equals 315. So dividing both sides by negative 105, and that gives me y equals a negative 3. Now we just have to put it back into the original equation. I'm going to use this one. So I got 9x plus 2 times negative 3 equals 39. 9x minus 6 equals 39. I'm going to add 6 to both sides, which then leaves me with 9x equals 45. Divide by 9, x equals 5. So my ordered pair would be 5, comma, negative 3. And that is solving linear systems by multiplying first. And hope this helps. Until next time.